Okay, so this problem deals with force pairs. It says, consider the following system, where force F equals 60 Newton, mass lowercase m equals 7 kilograms, and mass capital M equals 10 kilograms. What is the magnitude of the force with which one block acts on the other? So, as usual, we want to do a free body diagram. Let's do that. We'll call this one, this is the free body diagram for this mass, capital M. Therefore, its weight is mg. And then normal force, I'm going to do a capital M subscript. So we know that's the normal force related to this mass. This force is the force that we're looking for. If we had a wall, right, let's say we had a wall here, this one would be the normal force in a way, right, the force of the wall, normal force because of the surface. However, now because we have this mass, this is the contact force between the two masses. Therefore, I'm going to call it the force between two masses, capital M and lowercase m. Now we can do the free body diagram for the second mass. So for this one, the weight will be lowercase m and then g. Normal force, lowercase m. And then this force happens to be the same as this one, the contact force between those two. Okay. So now we have our two free body diagrams. Let's sum the forces starting with lowercase m, or the smaller mass. Let's start with forces along the x. Actually, I'm only going to worry about forces along the x because these two forces are going to be balanced and these two forces will be balanced. So I'll just focus on the x-axis. We only have one force for the second mass, or the smaller mass. And as we know, if there's only one force present, this has to be equal to mass times acceleration. And of course, this m is this mass. All right. Now let's sum the forces for the bigger mass. Notice how I'm using lowercase and capital M intentionally. So I will assume that the motion of this system is to the right. Therefore, force F is positive. And then because we have acceleration of the system, this is equal to mass times acceleration with capital M. Okay, what do we do now? We can use this equation and solve for acceleration so that we can express the acceleration of this block in terms of the mass, lowercase m, that we know and the force we're looking for. Because we don't know the acceleration, but we don't need it in this case. So if we divide both sides by this force, we'll get that the acceleration is equal to the contact force between the two masses divided by smaller mass. And now we can use this one here because the acceleration of the system happens to be the same. Okay, now we have known variables and only one unknown, which is the one we're looking for. We'll move this one to the right by adding. Okay, now we can factor out force of contact between the two masses. And then we would have to divide both sides by this. And that's how you would find it. So you can stop here and just plug in your numbers. If you want to do this in a more elegant way, just keep watching the video because I'm going to rewrite this denominator differently. Well, I'm going to go back to this step and do it slightly different so you can have a more elegant equation. Okay, for those of you who stayed, we'll rewrite this one in such a way that we have the same denominator as this term. We have lowercase m as the denominator, so I can rewrite this one as follows. If I have lowercase m over lowercase m, that is 1, equal to 1. Now I have the same denominator, so I can just make this into one expression. And now to solve for the contact force between the two masses, we just take the reciprocal of this one. And we'll have a more elegant equation to solve for the force of contact. And that's it.